Hello, everyone. So thank you for coming to listen. So my name is, first of all, a few words about myself. My name is Anatolii Kmetiuk. I'm currently a compiler engineer at LAMP EPFL, working on the Scala 3 compiler. And for the past 7 years, I've been working with Scala for various freelance projects, for various for all sorts of things. And for the past year on my current job, I've been involved in a porting effort aimed into porting an ecosystem of libraries that powers Ammonite into Scala 3. So we have a bunch of Scala 2 libraries, and the objective is to get them done in Scala 3. In this talk, I would like to summarize the efforts that have been done in the past year, and hopefully share the lessons that will hopefully be useful to other people that find themselves in a situation where they need to port code from Scala 2 to Scala 3, and hopefully it will be useful to them. And the relevance of this talk is that Scala 3 is coming soon, maybe at the end of the year, maybe next year. It will be released, and more code will want to get ported to Scala 3. So it is good to share the experience of porting existing code bases so that the experience can be reused. So what exactly ecosystem are we talking about here? So the ecosystem comprises around a dozen of libraries that all power the Ammonite. These libraries are written by Lee Howey. And Ammonite, for those who do not know, is an alternative REPL and a scripting solution for Scala. That allows you to write scripts in Scala. So the libraries that power Ammonite are the libraries that can also be used for day-to-day programming. So there are libraries for things like input-output, for interacting with the file systems, spawning processes, JSON, HTTP requests, web application development, testing, and so on. So I can see, okay. So as one of the challenges, so as you can see on the screenshot, there are these libraries, some of them are highlighted as blue or as red. So these libraries indicate the presence of either macros or interaction with the Scala 2 compiler. So the blue libraries on the screenshot, they contain macros, and the red libraries, they interact with the Scala 2 compiler. And why exactly is that important for the task of porting? Well, the answer is that Scala 3 uses a completely different metaprogramming libraries and metaprogramming framework than Scala 2. So if you want to port a library from Scala 2 to Scala 3, you will have to rewrite completely all the macros that are present in that library, if there are some macros present. So it is good to be aware of which libraries contain these things. And obviously we have Ammonite and Mill, which are highlighted as red, which indicates the presence of interaction with the Scala 2 compiler. And it is not surprising because Ammonite is a REPL and a scripting solution. So it must be able to interpret Scala code. And to do that, it needs Scala 2 compiler. And Mill is a build tool for Scala. And I am not exactly sure what exactly they do there with the interaction with the Scala 2 compiler. I believe they have some compiler plugins to build Mill itself, but the point is that they are present and they need to be taken into account. And the arrows between libraries indicate dependencies. So for example, if we have in the upper right corner, we have an arrow from source code to fancy, then it means that source code is a dependency of fancy. And we need to build source code first to be able to build fancy. All right, so how a typical process of porting of such an ecosystem, of moderately sized ecosystem, how does it go? So it all starts, the most obvious, the most relevant, the most reasonable place to start with is some zero dependency library, some entry point into the library. So in my porting effort, the first thing that I did was targeting microtest and source code, because although they are not shown here, like as you can see, microtest doesn't have any arrows going out from it. In reality, it must have arrows going from it to every other project in this ecosystem. Just that if you draw these arrows, the diagram will be unreadable, because microtest is a testing solution. It is a testing framework, and every single project in this ecosystem uses microtest for testing purposes. So it is reasonable to target as a project which has a minimal number of dependencies first, and which is a dependency of maximum number of other projects, because this opens the opportunities for porting other projects. So how exactly does it go, the typical process of porting such a library? Well, obviously, first you clone it. Then you're going to modify the build file to compile against Scala 3. Then you're going to go with re-implementing all the Scala 2 macros in Scala 3. And then you're going to work through the compilation and test errors. So basically, basically steps 3 and 4 are obviously intermingled, but the point is that you will have a lot of compile time errors that you're going to fix. So regarding the step 2, the modification of the build file is often not that complicated. So I may show you some live code that I have here. So I have microtest over here, and I have this is its build file, build.sc. So what typically, so Mil has an excellent support for Scala 3. So the way we port usually is like, at least this was the pattern with all the Ammonite projects that I was supporting so far, and that other people in the community were porting so far. So we just locate the things that we want to port. For example, this microtest JVM module over here, and it extends cross, which is a Mil language for cross compilation. So this module is a JVM module of microtest, which cross compiles between various versions of Scala. And then we just add the recent Dotty version into the list of the cross compilation over here. This fragment, you can disregard it, because this fragment is specific to Dotty community build. So basically, if you want to include this library into Dotty community build, we need this fragment over here. Otherwise, we would drop it. So the modification of this build file is straightforward. The most difficulty at the early stage of porting is going through this compilation errors, which again are also pretty straightforward. In fact, Scala Center has prepared this migration guide that you see here on the screen, a website dedicated to explaining how exactly to migrate from Scala 2 to Scala 3. It is still a work in progress, but it still contains something useful. Later in this presentation, I'll have a link on the slides to this migration guide. But the point that I'm trying to show here is that first, when you come to a porting project, first you encounter programmatic challenges that are comparatively easy to solve. If you know what you're doing, if you know the procedure, how it is done. The only exception is the re-implementation of the macros. For that, you will need to do some real programming, some real coding. Next, we get to a more interesting part of this talk, the one that's at least more interesting for me, how porting develops. So if at first you have your main challenges are programmatic challenges, which is how to modify a build file, how to fix compilation errors, how to write the metaprogramming system. Then as the porting progresses forward, you start getting more and more dependency related challenges. And by dependency related challenges, I do not mean dependencies as in Maven dependencies, because as I mentioned previously, we are working against a zero dependency library. By dependencies, I mean a dependency on the Dotty compiler, which is Scala 3 compiler we are porting to, and the dependency against the upstream project. the upstream project being the project that you're trying to port. So what is the first dependency? So the first dependency is Dotty compiler. Why is it important? It is important, well, it is still important in that way, but a year ago it was particularly important because Dotty was moving pretty fast, and moving fast means breaking changes. So it means that if your code compiles against today's version of Dotty, there is no guarantee that it will compile against tomorrow's version of Dotty. Now, today the things are a bit different because we are preparing to release the Scala 3 very soon. To do that, we try to stabilize the compiler. So now we are feature complete. So it means that no new features are added. No new features are added basically. So it also means less friction, less breaking changes. The only part that was moving actively forward last time I checked was the metaprogramming part, the macros part. So the point is that the movement of the Dotty compiler, can negate your work, because you do something and then there is a breaking change and it no longer compiles against the latest version of Dotty. Why upstream movement is important? Well, upstream movement is basically the movement of the project you're trying to port. So upstream refers to the upstream repository, the original repository you're trying to work against. So the way your porting usually works is that you clone the upstream repo at a certain point of time, and then you work against that particular version that you cloned. However, the point is that while you're working on your upstream, while you're working on your clone of upstream, the upstream itself may move forward. And that can also negate your work, because if it moves forward well enough into the future, then you will have to resolve a bunch of merge conflicts. So again, maybe I'll show you like the live repo, how it looks, at least how it looks, how the microtest repo looks. So here I have the Git management software for the microtest repo. We have two branches in it. So origin refers to our fork, which we use for the community build. So basically all of our community build projects, all of the Dotty community build projects, they reside in a form of separate forks, which are controlled by our teams. And this is done so that if we introduce some breaking change, we can fix the tests easily without the need to rely on the upstream maintainers to do that. Upstream is, well, it is upstream. It is the original repository that was cloned from. And let us see. So this is, so the checked out commit over here is current commit of the community build, at least as seen from my machine, but as you can see, the origin part of the repo went forward, and that is because some changes in Dotty made it necessary to make some changes in the microtest, and I believe these changes are just the metaprogramming changes, because as I mentioned before, the metaprogramming part of Dotty is only actively developing parts that I'm aware of to date that can still get the breaking changes. So as you can see, this purple branch that stems from the checked out commit, this purple branch over here, it is changes that we had to do recently to the community build to make it work with the new metaprogramming sim. But also we have here the upstream commit, and as you can see, there is a situation when we have this upstream branch and we have the checked out branch, the origin branch. And these branches, they tend to develop in parallel, this blue branch and the red branch. Now, in this particular scenario, it is all good because microtest is already ported. So over here, you can see I merge. So I merge from the from our origin branch into the upstream repo. But the point is that before that was done, there was a period of time when we were developing without getting merged, and we were developing in parallel with upstream. So why exactly is it bad? Again, because it can negate your previous work that you have done previously. And if you, like, I had a situation in practice where I was working on some port. Then I got distracted for other things, for about a month. And then when I came back to this port, I had to restart my work from scratch because the upstream just went too far ahead. So the point that I'm trying to make in this slide is that as you start on your porting effort, the main challenge is indeed programming. But as your porting effort progresses with time, the main challenge becomes not programming, but more of the repo management and Git management. Things get even more interesting when we go from porting a zero dependency library to a non-zero dependency library. So previous slide covered the situation which arises when we report in the zero dependency library, but this slide, it aims to present something that happens when you have ported already all the zero dependency libraries and you're going to libraries with other dependencies. So for example, Fancy is such a library. You can see it in the top right corner of the screen under source code. There is this Fancy library. It has the dependency of source code and microtest, so it is no longer a zero dependency library. So what challenges arise when you do that, when you have this library support? So what happens is that immediately you realize that before you even start porting that libraries that you want to port, you need to publish locally all the dependencies of this library. Otherwise, you will not be able to compile that. And the problem is even more aggravated when you go further down into the graph. So for example, library like Cask, for example, it is leftmost downmost library on this slide, highlighted in blue. It is a web application server engine. So as you can see, this library has transitive dependencies. So it has multi-level dependencies. So to start on porting Cask, you also need to publish Scala tags, micropickle, requests, and to publish Scala tags, micropickle, and requests, you need to publish Jenny. And also to publish Jenny, you need also to publish microtest and source code, because everything depends on microtest and source code, even though on the diagram the dependencies are not shown, but everything in this ecosystem depends on these two libraries, source code and microtest at the top right corner. So the point is that you need to have the capability of publishing the libraries quickly and efficiently. You need to have the capability to know which libraries to publish if you want to compile a certain library. And you need to do that, to be able to do that in a reasonable speed. And if you do not have this capability, then you do not even get to the programming part. And if you do that manually, if you do that in an ad hoc way, then the problem will not go away. You will have a great sense of brittleness over your build, and it will greatly interfere with your work, and it will be the main source of trouble when porting a library. So this kind of problem of transitive dependencies, of just simply dependencies, it is aggravated, and it actually aggravates the problem of moving targets, because not only you need to keep in mind the two moving targets of the single libraries that you're porting, you also need to keep in mind the moving targets of the dependency libraries that you have. So you really need to get the publishing capability right, so that it doesn't interfere with your work. Another very interesting problem is that sometimes libraries depend on earlier versions of other libraries which aren't ported yet. So let me show you what exactly I mean. So let me see, maybe I have some library here with dependencies. So for example, pprint. So pprint, let me have a look. Let me show you this slide again briefly so that you see where pprint is on the big picture. So if you look at the slide, there is source code at the top right corner next to microtest, to the left of microtest. If you look at that source code library, down from it to the right is fancy, and down from fancy is pprint. And pprint is a library used to pre-print types. So if you have, for example, a list, or not only types, but also data structures. So if you have, for example, a list, with the help of pprint, you can pre-print it. So pprint is a library with dependencies. So let me go show you these dependencies. So yeah, for example, fancy. Now, what exactly can go, how exactly can this dependency cause you trouble? Well, it can cause you trouble because fancy must be ported before pprint starts to be ported. But this part we already know, right? We have covered it earlier. The real trouble starts when this pprint over here, it depends not on the latest version of fancy, 0 to 9, but for example, 0 to 8. And that version, for example, happens to be developed roughly, for example, a year before now, even before the time when you even started porting fancy, which means that you have 0 to 9 ported to Dotty, but not 0 to 8. And you need 0 to 8 to compile pprint. So the added consideration here is that you will have basically to upgrade all the libraries of the project. If it was 0 to 8, it will become 0 to 9, or whatever the latest version is here. And by the way, don't quote me on when exactly 0 to 8 was released, maybe not a year ago. That's just a rough example. But the point is that this is a consideration to keep in mind, and the easiest way around this consideration is to bump your dependencies to the latest version and to port the latest version. In some ecosystems, it might be a problem if porting a library to, making a library depend on a later version of another library can cause extra friction. Okay, so to summarize this part, we can summarize this part with one single sentence. You need to be able to control the graph. You need to be able to control the graph of dependencies if you want to port an ecosystem, or else it will be pretty difficult. So how did what solutions did we come up to mitigate these problems during the porting effort? So first of all, the implementation challenges. The implementation challenges are the challenges that arise when you just start implementing or porting a library, and they're pretty straightforward. There are programmatic issues, like, for example, like on this slide, you have a screenshot of some errors, and the errors say a symbol literal is no longer supported. And this is because Dotty indeed does not support that symbol literal syntax. So you cannot just write single quote and then some string, and it will count as a symbol literal. So there is a rule you need to use to rewrite it to work with Dotty. So there is this nice migration guide that I showed you previously, which was composed by Scala Center, by LAMP, to address all the incompatibilities and to facilitate the porting process. It is still a work in progress, so but still it can be useful. And maybe if you have some Scala 2 to Scala 3 porting project, you may want to contribute to this guide a little bit if you find something. So yeah, as you can see, it has some resources to help you. But ultimately, it will boil down to working the compile time errors, and then work in the macros, and then work in the tests, the runtime stuff. The more interesting part is how we mitigate the dependencies challenges, at least how I do that in my workflow. So what really helps to mitigate these dependency challenges, this two moving targets problem, for example. So what really helps to do that, to mitigate that, is slowing down your moving targets, which means that it is pretty difficult to target every latest nightly release of Dotty, because you will be, if you, for example, have a project that you're trying to port, then I would not recommend you to update the Dotty version every day, as we release nightlies. I do not recommend to compile against the latest version of Dotty. Why? Because sometimes there are breaking changes. I'm not aware about the situation now, but a year ago it was certainly the case. My guess would be that now it might be the case with macros. Most probably will be the case with macros. But otherwise we are aiming for stabilization, of course. So why do you not want to port that, why do you not want to target the latest Dotty versions? Is because it will considerably slow you down, because you will constantly have to work through the breakages introduced by the changes across the nightlies. So my mistake that I was making when I was first doing the porting efforts was to publish Dotty locally every day and compile these projects with the locally published version of Dotty. And that turns out to take a lot of time from you. So what I do now is I target only stable releases of Dotty. And by stable releases, I mean, I can show you again the code. So for example, here we have pprint. Let us see how exactly it is ported. This is its build file. Let's see where we specify the Dotty version. So this is the Dotty version. So if it has this format 0, 27, 0, RC1, it is a stable version. You can find the stable versions on the Dotty website. On the Dotty GitHub repo, tags. So it helps to target them because they are only released once every 6 weeks. So you need to deal with these problems only once every 6 weeks. Next thing is do not sync with upstream until done porting. So if you're doing porting and then you see the upstream go ahead, there might be a temptation to just rebase on the latest upstream or merge the latest upstream. But again, for the same reason as not tracking the latest Dotty version, you shouldn't track the latest upstream version. Why? Because it interferes with your work, and you will end up distracted every day on this kind of rebases. Having said that, you also need to take care to speed yourself up, or else Dotty might go just too far ahead, or the upstream might go just too far ahead, and give it enough time and you will have to restart your work all over again. Another thing that helps to mitigate the challenges of dependencies is to basically implement a robust system that will allow you to manage the dependency graph easily. And by management the dependency graph, what I mean is you should be able to quickly compile any library of your dependency graph, to quickly publish it, to quickly test it with one command, and it should be very readily available, so that if you quickly need to republish something, you can do that very easily, and do not distract yourself on that, because it will take just too much time if you do not have such a system. So given this description of the challenge, of the problem, as in having a way to quickly manage that graph, it sounds very much like an engineering challenge, and temptation might be to just write a software solution to manage your dependencies, to manage your ecosystem, to have something like a mini build tool. And that was exactly what I did in the early days of my porting effort. I made this nice little application, which is currently available on GitHub. There will be slides. I believe the slides will be published in the post blog for this conference. You will be able to click on this to access the project. So this little project that you can see on the screen, it is aimed to, first of all, provide you an ability to control the community build of Dotty. So, which means it is not only for the projects that I'm porting and that other people are porting, the projects that are related to Ammonite. It is also the REPL, that the project that is used to control the entire Dotty community build, because community build is also an ecosystem, so it also has its own dependencies. Well, at least it will have its own dependencies, and we need a way to control it. So why not just write a general solution to control everything? So the solution is a small REPL, which where you can input commands, and it will show you some information or execute some stuff that needs to be done. So for example, on the screenshot here, you see this check command, and the check command is supposed to run the sanity check on all of our community build projects. So the Dotty community build is a set of libraries that we test the Dotty compiler against. So basically the idea is that we have this set of libraries, and every Dotty change that we make, we test after every change that we make, we test whether the compiler is still capable of compiling all of the projects in the community build. So the challenges that might arise when managing a complex community build is that again, it needs to stay up to date with the upstream, and also some technical stuff we need to take control of, such as branch naming conventions, such as CI tracking, the continuous integration tracking. So this little REPL here was aimed to solve all of these problems by this check command. It was able to provide us in red in front of every project the stuff that needs to be fixed. For example, for falling behind the upstream, we have the behind column. So for example, the topmost project, we can see that it has the number 6 at the behind column, which means that it is 6 commits behind the upstream, and 3 commits, number 3 is in the ahead column, which means that it is 3 commits ahead of the upstream, which means that we did some changes that are not in the upstream yet. So on first sight, it was a good idea. I can quickly show you it in action, this little REPL in action. So I have it open over here. Well, it turns out that the most useful part where I was using this REPL was not the sanity checks, but the little show command. So the show command as an empty command, it just lists all of the projects registered in the system. But if you try to show, for example, microtest, then it shows all sorts of interesting information about it. So we have some metadata over here, the names, the link to the fork of the project, the link to the upstream of the project. And also it has the commands. So it has commands that we can use to compile this project, to test this project, to publish locally the project, etc. And theoretically, this REPL can also do the testing of this project for you. Like if you run test microtest, for example, it is supposed to run this command automatically for you. But ultimately, this solution was deemed by me as a bad solution. And why exactly it is a bad solution? Let me show you again as an example of this live REPL. So while SBT is loading, I can just say that it is not a very good solution because it breaks very frequently. So it turns out that the workflows that we have in this community build are pretty complicated, and there are interactions with the Git API. So for example, to fetch the commits behind, commits ahead, we need to interact with the Git repositories of the corresponding projects. So let me just run this check command over here. And yeah, it tries to pull the latest dirty changes. It tries to do some stuff, and bam, we have a runtime exception. We have some repository not found exception. So the point is that at a certain point of time, I have this big solution. It bloated to 700 lines of code. And at a certain point of time, I realize that I spend more time maintaining this solution than actually porting libraries. But I still need the capability to control the graph and to publish these libraries. So what I did is I just realized what is the most frequent things that I'm using from this REPL. So we have a lot of commands over here, as you can see in autocomplete. So if we go with the show command is actually the most frequent command that I use, because it provides me the commands that I need to compile a certain project. So show microtest again. The only thing I need from here is these commands, and due to other various reasons, which I will not go in depth into, I'm not even using frequently this test or compile commands, even though they work decently. I still do not use them because, well, it has to do with dependency. It republishes dependencies sometimes when I do not want them republished. So basically, it doesn't work for me because it is too bloated, it is too error prone, and I just basically realized that while trying to solve one problem programmatically, I created 10 other problems. So yeah, it doesn't work because of the GitHub API and also flexibility issues. The stuff that I forgot to mention is flexibility issues. So if I go to this REPL, I have this commands over here. The question is, what happens if I want to modify the command a little bit? For example, use the mil that is not that doesn't come from the repo itself, but the ones that comes from my operating system. What do I need to do? Well, it's easy. Comparatively, I go to the .ecosystem code base. I go to sources. I go to the place where my projects are defined. And in this project, I have a bunch of definitions of the project. So we're working with microtest, right? So I find microtest here. And if I want to modify this mil command over here, if I do not want it to come from the repo, I'll just erase it over here. And then I'll restart the repo, recompile the entire REPL, and I'll have that command. Again, it is not very flexible because it just takes time. It just takes time to restart the scenes and to change the scenes. So what is the current solution? What is the silver bullet that actually helps me developing and importing these libraries so far? Yes, it is not a Scala project. It is not any programming language project. It is a Google Sheets project. So let me show you what I have now, what setup I currently have. So currently I have the following spreadsheet with all the commands that I need to do the work. So again, we have this microtest command for testing, source code, Jenny, all the libraries go into this table. We have here the name of the project. We have here the commands that we need to run. If I want, for example, not to test, but to compile it, I'm going to select compile over here. It is going to modify the command very easily. If I want another mil executable, again, I modify the mil executable. For example, to the one that comes from the mil repo that is a local clone of the mil repo. I turn it back to the one that comes from the repo that we cloned. Then say I want to modify the Scala version. I do the Scala version, I set it like this, for example. And say some project has a completely different command that doesn't follow a pattern. I just input it here in plain text. For example, if cask uses SBT, I'm going to just write SBT and whatever, run or SBT test. And obviously it is quite easy to just hook it up into the into this task scene over here, and it will work. So why exactly I maintain that this solution is better than a programmatic solution? Well, here are my reasons. First of all, like the reason that is most obvious reason for me, the most heavyweight reason for me, is that 25 lines of text replaces 700 lines of Scala code. So for me, every time I subtract code without losing functionality is actually a much greater win than a time when I add code. Why? Because 99% of the cases, whenever you add code, you add bugs. This just repeats from project to project, no matter the code base, no matter anything. It is just too complicated. Software is just too complicated. So when you write software, you create bugs. And that project that I've been working on, the REPL to maintain the ecosystem, was just a very good example for me, that I wrote this huge, like 700 of codes solution that perfectly solved one problem, created 10 other problems. So 700 lines get replaced by 25 lines of text, and not code. If you want to count, if you do not want to count the Excel formulas as code. So this is a great win already. No runtime exceptions, much easier to track the behavior. Also, it is flexibility, as I showed you before. It is much easier to modify the commands. Just double click and edit a string. No need to recompile anything. No need to navigate through the code base. Just change the string. And it also allows to store extra data. That was actually unexpected to me, but that was a great help. So let me show you what I mean. So here again, we have the spreadsheet. I have not only project, not only command, but also the fork, the upstream. So fork is the link to our fork. Upstream is the link to our upstream. So if I want to go quickly to the upstream repo, I just click here, and I'm there. So very easily, I store extra data. Also, it allows you to store not only the static data, but the data that frequently changes. So I have here the status column, which reflects the current status of the project. And I have also the PR status, the PR column, which reflects all the relevant PRs that might be in flight. So every time I have a very easy top-down view on the current status of the ecosystem. So for example, I have here that, for example, I have the information that Cask has this in-flight PR. I just go to this PR very easily. And then I see that it is merged. It is port done by Jakub Buderski. So it is already merged. So in this sheet, I can just remove the PR, and then I can just write in the status like PR merged, work in progress, release to Maven. And this way, I clearly see what needs to be done for every library. And that's not to mention the graphical aspect of spreadsheets. So I can have this reference diagram over here very easily, so that if I want to build, for example, I don't know, request library, I can easily see its dependency, Jenny. I can just go to Jenny. I can just select publish local. I can just copy that and paste that into Jenny's fork, and it will publish me Jenny. So that solution gives me much less headache, much more flexible due to less size, and it solves the problem perfectly. So to wrap this talk up, what exactly did we learn in the process of porting the Ammonite ecosystem? So in my experience, the biggest challenge when porting an ecosystem of libraries is not a programming challenge. Yes, it is true that sometimes you will have to write some macro code. It is true that sometimes you will have to work against the compile time errors, but the bigger issue is how to track different projects that you depend on, and how to mitigate the fact that other people also work on them, and they introduce breaking changes all the time. So if you do not solve that problem, it is going to be the biggest source of your problem. you will spend most of your time managing that ecosystem and not doing actual programming. So that really needs to be solved if you want to be productive on a port. Another thing is how to actually mitigate these things, how to actually work in this complicated environment, complex environment. Well, first thing is to slow down your moving targets, make the environment as static as possible. So maybe do not update your dependencies as frequently, maybe do not update your compiler dependencies as frequently, maybe do not merge the upstream branch into your branch too frequently, do not rebase too frequently, because it is going to slow you down. And the most important thing is to get as much control and awareness over the environment as possible. So if you do not have the control and the awareness of the environment you're working in, I mean the graph, the dependency graph, you will quickly get overwhelmed by the fact that you need to publish things locally, you need to test them, and you don't have one way to do that. So it really needs to, you really need to get that right. So you need to identify what actions you frequently do, not necessarily programmatic actions, dependency related actions, what information you need, and make them accessible from one place. And to date, that Google Sheets solution works wonders for me. So yeah, this wraps up my talk.